Hello guys, in this video I am going to explain the solution of question number 24 of chapter 10 from the book Engineering Circuit Analysis, which is the 8th edition of and written by Hayt, Kemmerly and Durbin. So the question says that we need to employ a suitable complex source to determine the steady state current IL, means this, in the circuit. Now with complex source, what it means that we need to write this expression in the exponential form, and the expression in the exponential form it can be written as 5 e power j 35 t minus 10 degree, right? So this is the suitable complex source. It is a complex form of this, right? So simply whatever is the angle that we need to put in the power, right, along with j, right? So using this complex exponential form we are going to determine the IL. So as per one of the concept of the complex source, it is said that because we know that for the circuit having the capacitor and the inductor, the omega is not going to change. This frequency is not going to change. The change will be in the amplitude and in the phase. So considering this point, what we can say, we can assume that our IL is equals to IM, means we have assumed that the amplitude of the current, it will be IM. And now writing this complex function, we will write omega. Now omega is not going to change. This 35t is not going to change with the presence of inductor and capacitor. So we write exactly in this form, 35t plus, now over here we can write this as minus 10, right? So simply we write this 35t minus 10. So let this be the current. Now over here what we are trying to do, and what is there as per the concept, that by assuming this, if there is a phase shift, that phase shift will be present over here, right? And from this we will get we will determine the phase shift, and then later on we will add to this phase. So over here we do not, this expression it will remain as it is. Only change that we will put, it will be the IM, right? So now considering this, what now we need to solve this. Now how to solve this particular circuit? We already assume that IL is equals to IM e power j 35t minus 10. Now applying the mesh analysis, like let it be I1, let it be IL, because IL is already there, right? And let this, instead of I, let it be IS. This is our IS. So now since in the first loop already we have a current, this is a current source, so it means that our IS, it is 5 e power j 35t minus 10 degrees, right? And now applying the KVL in this loop, so what we will get? We will get first this. So over here plus minus, so 6IL. Then coming to this, over here if I is the current, then V will be expressed as L is 0.4 DIL by dt square, dt, not square, dt. So because we know that for the inductor VL is equals to LDI by dt. So from this we get this, right? Now coming to the capacitor. Now for the capacitor we know that I is equals to C dV by dt, right? So it means that V is equals to 1 by C I dt, right? So over here in the capacitor the current is one current is IS, another current is IL, So it means overall current, it will be IL minus IS. So it means it will be 1 upon C IL minus IS dt. So substituting this over here, I will get 1 upon C, which is integration IL minus IS dt equals to 0. Now to remove this integration, what we can do, we can differentiate it. Differentiate the complete equation. So our equation, it will become 6 DIL by dt plus 0.4 DIL square by dt square plus 1 by 0.01, or simply we can write it as 100. We can put it as 100, and this will become IL minus IS equal to 0. Right now in this equation we just have the differential terms. Now we already have assumed that IL is this, right? So from this assumed, we will get DIL by dt. So we will get IM e power j 35t minus 10, and we know that the differentiation of this term e power something, it will be same, plus we have 35t, so and along with j, so we will get 35j IM, right? And double differentiate it because we also need this for this. So d2IL by dt square we will get again 35j square IM e power j 35t minus 10, right? So since this is j square, so we know that j square is equals to minus 1, right? So we can remove this j square and simply we can write minus 35 square, right? So we, from this we now know this and this. Substituting this value in these equations, we will get 6 into 35j IM e power something something, means you can see that e power is over here, e power is over here, and e power is over here, right? So this e power, it is going to be cancelled out. So it is the reason that presently I am writing, let me put it as x, right? This complete, this I substitute, x is equals to this j 35t minus 10. So let x is this, because at the end it is going to cancel out, plus 0.4. Now it is this, so it will be 0.4 minus 35 square IM e power x plus this is 100. Now IL it is this, right? So IM e power x, IM e power x minus IS. Now what is IS? IS is this 5 e power x. You can see over here also power is same, so we can write 5 e power x. Okay, over here it is, so 5 e power x. Now from this equation you can see e power x, e power x, e power x, e power x can be cancelled because it can be taken as common, so it can be cancelled. And now solving this equation, we will get like 210 j IM minus 490 IM plus 100 IM minus 500 equals to 0, right? So IM will be equals to 500 upon 2 minus 390 plus 210j, right? And now this two expressions somehow we need to solve. So if I convert this numerator and denominator in polar form, so it will be this upon this will be 442.94, angle is 151.70, right? So it can be written as this 500 divided by 442.94, angle is 0 minus 151.70. So we will get the answer as 1.13, angle is minus 151.70, right? 70. Now this is our IM. What is our IL? IL is our IM. It is IM e power 35t minus 10. So e power j 35t minus 10, right? So it means substituting the value of IM. So our IL, it is 1.13 minus 151.70 e power j 35t minus 10. Now this is our phase that will be added, that need to be added over here, right? So it is minus 151. So simply we will write 1 e power j 35t minus 10, and since it is in minus, so minus 151.70, and then it will be 1.13 e power j, it is 35t minus 161.70, and this can be expressed as 1.13 sine 35t minus 161.70, right? So our IL, it is this. How I come from exponential to sine? Because in the starting, like in the starting of the question, let me show you. In the starting of the question, it is given that our current source, it is in sine wave. It is in sine wave, and it is where we convert this sine wave into the complex form, right? So at the end, when we get the IL in this form, then we need to convert it back to the actual sine or the cosine form. Over here it is sine, so I convert it back to the sine. It is 35t, so it is 35t, and so on. So it is the reason that simply once I get the answer in exponential form, then straight away we can convert it into the sine form. So this is the answer to this particular question. So if you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.